All right, let's start the second half of the Unit 2 review. So we'll start with 4.5, and that was solving equations by factoring. So letter A, what would you need to do to solve this? Well, first thing, you need to get a 0 on one side. So I'm going to add the 2. That would give me 12x squared plus 40x plus 12 equals 0. Okay, so now you could go ahead and factor using the perfect square trinomial, or not perfect square, just the trinomial product sum thing. But with these numbers are kind of big, so let's see if there's a GCF we can take out of it. And it turns out there is. We can take a 4 out of all of these. So this becomes 4 times 3x squared plus 10x plus 3. Okay, so now I can do that thing. I need two numbers that multiply to be 9, add to be 10. That'll be 9 and 1. So you still have that 4 out front, but then we can factor by grouping. Okay, so keep going. Sorry, I'm not talking much. I'm just assuming that you're comfortable with factoring. Okay, so we get here, and then some people, this 4 throws them off. And remember, you need to set each piece equal to 0. So 4 equals to 0. That's because 4 is its piece, or is a piece in its own right. So since there is no variable, this part right here would be no solution. So really, the 4 does not play a role into this problem, how we did it. If you would have kept it and factored, like up here, two numbers that multiplied to be, what would that be, 144, and added to be 40, you would still get the answer, same answers that we're about to get the way we did it. These just numbers are much more pain in the butt. Okay, so set each piece equal to 0, so I have negative 1/3 and negative 3. All right, the next one, I'm gonna go really quick, move the 3 over. So I have 2x squared plus 7x minus 4 equals 0. I need two numbers that multiply to be negative 8, add to be 7. That would be 8 and negative 1. Rewrite it so we can factor by grouping. You can take a 2x and a negative 1 out of those next two. So you have 2x minus 1 times x plus 4 equals 0. X is 1/2 and negative 4. Sorry, I know I went fast. I'm just trying to save time in the video. Okay, so now section 4.6 about solving quadratics with using roots, where you get the x squared by itself, and then also completing the square. So these ones, since there is no term that has just an x to the first power in it, usually the easiest way to solve these is by isolating the radical. So we're going to isolate that x squared by subtracting 9 first. And that gives you 36. Divide the 4 off of there. You get x squared equals 9. Square root, x equals what? Plus or minus 3. Must have the plus or minus. Okay, next one. Add 8, 2x squared equals negative 20. Divide by 2. X squared equals negative 10. Square root, x equals plus or minus I square root 10. Okay, now completing the square. So you will have to do this on your test. I remember a couple problems actually. So first thing when you're doing this is move the c to the other side, then complete the square. The formula is you take the b term divided by 2 squared. and you add whatever that is to both sides. Factor your perfect square trinomial, square root both sides, and then solve. So let's do it. First thing they said is move the c over. So subtract 54 minus 54. This is the one where you put the blanks in there. So I have x squared minus 20x plus blank equals, what would that be? Negative 51 plus blank. Okay, so let's complete the square. Our b term is negative 20 over 2 squared, which was give me negative 10 squared, which is 100. So I'm going to add 100 there and add 100 there. Okay, on the right side, you get 49, and this factors into something. And if you notice over on the left, when I was doing my perfect square, or completing the square, I did this step right here that you probably can do in your head, but I like to write it because it translates over to here. So whatever you get in that step right there, for us it's minus 10, goes with the x. So it's x minus 10, or if it was a positive, you would say x plus 10. Okay, so now here we are, we've got that all done. We have x minus 10 squared equals 49. What do we need to do? The answer is square root, square root. So x minus 10 equals plus or minus 7. So now I need to add that 10 over. So I have 10 plus or minus 7. So remember, it's two answers. So 10 plus 7 would give you 17. 10 minus 7 would give you 3. So x equals 3 and 17. Okay, same one for this one. Add the 14 over. X squared minus 2x plus blank equals 12 plus blank. All right, so negative 2 over 2 squared is negative 1 squared, which is 1. Okay. Now factor, it looks like I have 13 on the right side, and this would be end up being x minus 1, because over there on the right side. Then square root, x minus 1 equals square root 13. You cannot square or take the square root of that. It's not a perfect square, and there are no perfect squares that go evenly into it, so I'm going to leave it as plus or minus square root of 13. Add 1 to both sides. So x equals 1 plus or minus square root 13. Okay. Next problem, the quadratic formula. So it is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yep, I just went there. Okay, so use the quadratic formula. First thing we need to do on this one is we need to get the 33. We need to get a 0 on one side. So I now have 6x squared plus 7x minus 33 equals 0. Now plug it into your handy dandy quadratic formula. Okay, so I've got negative 7, that's 12. So that gives me plus or minus the square root of 841. Square root that, and I get negative 7 plus or minus 29 over 12. So negative 7 plus 29 over 12. That would give you 22 over 12, which would end up being 11 sixths. And negative 7 minus 29 over 12 would be negative 36 over 12, which would end up being negative 3. So your two answers are negative 3 and a good old fraction, 11 sixths. Okay, next one. Gonna move the 9x over. So I have 9x squared minus 9x plus 4 equals 0. plug it in to the quadratic formula. 9x squared minus. I think we are going to end up with an imaginary. That's all right. Ooh. Okay, so sorry if I went too fast. 9 plus or minus negative 63, square root of negative 63 over 18. We can break apart the square root of negative 63. It breaks up into negative 9 and 7, which ends up being 3i square root 7. So this answer is 9 plus or minus 3i square root 7 all over 18. But you need to check, can you simplify all of your real numbers or rational numbers out front? And the answer is yes, you can divide all of those by 3. So you end up with 3 plus or minus I square root 7 over 6. That's your answer. All right, circles and completing the square. Okay, we're getting down to the, maybe not the end. Okay, so sorry. Standard form of a circle is x minus h squared plus y minus k squared equals radius squared, where your center is at h, k, and your radius is r. Okay, so find the radius and center of the circle and then graph. So the center, remember, the formula is minus h and minus k, so you have to do the opposite for the center. So this center would be 4, negative 2, and your radius would be the square root of 25, which is just 5. So we're going to start over here at 4, negative 2, and then go 5 in all directions. And then do your best to draw a circle. That's kind of ugly, but it's fine. Okay, next one. This one's the one that's a little bit harder. So this is not in standard form for a circle, so we need to convert it. So we're going to have to complete the square twice. First thing, let's move that 12 over. We're also going to regroup and put the x's together and the y's together. And then we're also going to have, since we're going to have to complete the square twice, we're going to add 2 blanks on each side as well. So let's do it. Be x squared plus 10x plus blank plus y squared plus 12y plus blank equals, and then when I move that 12 over, I have negative 12 plus blank, so don't forget there's 2 blanks. All right, let's complete the square for the x's. So I've got 10 over 2 squared would give me 5 squared, which is 25. So I got to add that in to both sides. So this factors now, just the x portion factors to be x. And then in that second step, I got a positive 5. So x plus 5 squared plus, now let's do the exact same thing for our y's. We have 12 over 2 squared, which would be 6 squared, or 36. So this would be y plus 6 squared equals, good old, hey, it worked out pretty nicely, equals 49. Okay, so now what is my center? My center is at negative 5, negative 6, because remember they're the opposite. And then my radius is 7. So let's graph this. It is going to be a little bit off of the graph, and that's okay. I'm trying to go fast, so I'm just kind of winging it. It's not the prettiest. Ooh, or it might be the ugliest. Okay, so this next problem is kind of gross. So actually, I'm going to change these problems because they are gross and there's a lot of fractions and decimals and stuff. So let's change it to y equals x squared minus 4x plus 2. And then the second one, change that to y equals negative x squared plus 4x minus 4. Okay, so these are in standard form. The first part of Unit 2, we reviewed how to graph standard form. So if you don't remember, go back and watch that part. So the axis of symmetry is what we need to find first. Negative b over 2a, and I'm going to do that top one. Okay, so we've got negative times negative 4 over 2 times 1 would be 4 over 2, so just 2. And then we're going to plug that back in to the original equation. So 2 squared minus 4 times 2 plus 2. What would that be? I believe it is negative 2. So your vertex is at 2, negative 2. And then lastly, your y-intercept is at 0c, so 0, positive 2. Okay, let's do the exact same thing for the blue one. So I've got axis of symmetry, negative 4 over 2 times negative 1 would be negative 4 over negative 2, which ends up being 2. Your vertex is negative times 2 squared plus 4 times 2 minus 4. What would that be? I think it's 0. Yes, it is. So we've got a vertex at 2, 0, and then lastly, our y-intercept is at 0, 2. Okay, so I need to graph these two. I'll do the red one first. So I've got I guess the axis of symmetry is the same on both of them, right? So I could just leave that. I'll do it in a different color. So it is at 2. And then for the red one, my vertex was at 2, negative 2 right there. My y-intercept was 2, and then it went over to this way. So I have this, and then let's try to connect it. Okay, and then the next one is your axis of symmetry is at 2. I already graphed that. 2, 0 is your vertex. And then, I messed up on your y-intercept. You probably already saw it. I was looking at the other one. Right here, this y-intercept should be negative 4 because I was looking at the wrong problem. So negative 4 would be our y-intercept. And it will look something like this. So what is the answer to this thing? And the answer is actually where they connect. And they connect, let's see if I can highlight it, right there at those 2 coordinates. And the reason it's where they connect is because this is a system of equations. So you got to tell me the coordinates of where they connect. So that would be 1, negative 1, and then also 3, negative 1. Okay, that's the solution to this system. Alrighty, and then here we go. We've got, actually, here's what I'm going to do. For this problem, I don't want to waste the time in the video to go through all of that to graph these two again. So what would happen if I changed this blue symbol to greater than or equal to, and then I changed the other one to greater than or equal to? So I would shade above on both of them, right? So where would that be? That would be right here in this region right here. So if I change those equal signs to inequalities, that's what it would be. And what kind of answer would that give me? Well, the answer is that would be an unlimited amount of answers because there's an unlimited amount of points. There's an infinite amount of points in that shaded region. All right, so if it's equations, it's going to give you coordinates. If it's inequalities, you have to draw the graph because it's a region and you can't write that down. You have to see the picture of the graph. Okay, last bit is complex numbers. Let's talk about all the properties. So I plus I is 2i. I minus I, 0. I times I is I to the second power, which equals -1. That is the biggest thing about i's that you need to remember is I to the second power is -1. Okay, then the next one, I divided by I is 1. Okay, so let's simplify. 12i minus 7i would be 5i. 4i minus 2i plus 3 minus 4i. So what are all these parentheses doing? And the answer is nothing because they're saying to add them. So that's just how they write them. So don't let it mess you up. You don't need to distribute anything. You just combine your like terms. So this would be 7 minus 6i. And notice you write the real number first and then the imaginary second, always. Okay, let's distribute. So this would give, since these are being multiplied, you have to distribute and FOIL it out. So 16 minus 4i plus 4i minus I squared. In the middle, they cancel out. So we have 16 minus I squared is -1, so minus -1 would become plus 1, which would make this 17. Next one. Now the parentheses are doing something. Since you're subtracting, you need to distribute the negative to the second set. Okay, and then you just combine like terms per usual. So that would be what? -1 minus 2i. All right, the fun part, rationalizing the denominator. So you remember you cannot leave i's in your denominator, so you need to multiply it out. Since this is, there's a couple different ways to do it. Since this is a monomial on the bottom, so just one term, you can multiply the top and the bottom by just a regular I, because watch what happens. You multiply the top, you get 4i, and on the denominator you get 2i squared, which remember 2i squared is actually -2, because I squared is -1. So I have 4i over -2. Well, you can simplify that and it ends up being -2i. Kind of fun. All right, next one. We need, since this time it's a binomial on the bottom, it's a little bit more of a pain in the butt. So we need to multiply it by its conjugate. Okay, so go ahead and distribute it out. You'd have 6 plus 3i on top, 4 plus 2i minus 2i minus I squared. Those two cancel out. Minus I squared ends up giving you +1. So this is 6 plus 3i over 5. Then last thing you need to do, can you simplify all of the real numbers? The answer, or rational numbers, I would say coefficients. And the answer is no. So you are done. All right, that is it for Unit 2. Thanks for watching. Have a great rest of your day.